So next we'll have lightning talks. There is a board in front of us. People have listed down their topics that they want to talk about. If you have listed a topic here, please come forward. The first topic is resource and cost optimization on planet scale Kubernetes. Second is solar powered monitoring with Prometheus. We have very interesting topics. I hope we had more interesting topics in open spaces as well, but very specific. So we'll try it. If you are here and if you're not here and your topic is here, we'll just move on to the next topic and we'll get a chance to do it again tomorrow. So yeah, we'll get started with Rahul.
Yeah, nice to see you all here at DevOps Days India. Almost after 2.5 years, a conference happening in person. So today I'm going to talk a little bit about resources and cost optimization on planet scale Kubernetes clusters. So all the day we are mostly talking about containers and Kubernetes and how to do this and how to scale all this stuff. But there are certain challenges when you are using something like container orchestration tool like Kubernetes on this scale. So we'll just check on how the real challenges happen in production and what are the few ways to address them. So myself, I am Rahul Mahale. I work as a principal DevOps engineer at Circle, circle.so, and that's my Twitter handle. So on larger Kubernetes clusters with nodes greater than 100, 500 or 1000, you might be using multiple clusters or you might be using a single cluster with a lot of API traffic. You might be having managed, self-managed node groups. You should be having hundreds or thousands of services and ingress controllers and a number of pods. That also includes your stateful or stateless workloads like storage and disk, and at the end the distributed services like if you are deploying databases like MySQL, Elasticsearch, Redis or Cassandra on Kubernetes, that's deployed in distributed style on Kubernetes cluster. So a few things is like when you spin up a Kubernetes cluster and deploy on it, we just an auto scaling using cluster autoscaler or Carpenter or using the cloud managed autoscaler, we think it's done. And Kubernetes, it's assumed as of now is like if you want to deploy anything, Kubernetes is there and it is going to work. And at the end of the day or after some quarters or review meetings, it turns out that we started using containerized platform and the resources and costs is going up. So how does that happens? That is because there are a few things like if you are using multi-AZ node groups, the traffic between the Kubernetes pods and services is being interchanged across the availability zones, and public clouds like AWS or any other will call you, will charge you on the data transfer. So for that, what is the solution? You can use something like as service mesh. Istio, Cilium are popular, one of them Linkerd. There is also AWS App Mesh. You can use that for multi-AZ setup, which will help you in minimizing the data transfer across the availability zones, and you can save on your traffic. But the thing to note is AWS's App Mesh till date doesn't support a topology aware routing, meaning that if you are using AWS App Mesh on EKS, it is not going to help you in cross availability zone data transfer. So for that, you have to use Istio. Also, we are using multiple resources in the same cloud, maybe databases or something. You should be using VPC endpoints instead of internet endpoints. Like if you are pushing and pulling from S3, you can use VPC endpoint instead of using the HTTPS S3 endpoint. For load balancers as well, if your traffic is heavily, if your site is heavy traffic, you'll get millions of requests and that. So that also turns out to be into the multiple availability zones. For that, you can use IP mode. And for clusters with larger worker nodes, we all know that Core DNS takes care of the DNS part in Kubernetes cluster, you can minimize the traffic to core DNS. It's not possible to like limit core DNS because it is the DNS of Kubernetes cluster. You can use something like node local cache. And also you can use the smaller images. That's one of the standard practice. And if you are running workloads for non-production systems, consider using spot instances. Spot instances are way more cheaper than the on-demand instances, and that helps you in saving a lot of cost. Apart from that, you can also use savings plans and other cost-saving techniques provided by the cloud provider as well. Also, choosing a right instances type, as of now, the gravitational series is making its mark in the public cloud. That also helps you in saving the cost. The very last example about how to mitigate the additional cost. In the last talk, we heard about Elastic. If you are deploying Elasticsearch stateful set on Kubernetes with 3 nodes, it might get allocated to 3 nodes which are in different availability zones. And if you are ingesting 1 TB of data on Elasticsearch cluster, which has 1 TB of data, all the 3 pods sitting on 3 different nodes will cause a lot of GBs of data transfer per day. So to avoid that, you can create a different node group in the single AZ if it's non-production and if it's acceptable, and that can be help you in saving the data cost. So yeah, thank you.